The Big Bang, a cosmological event that started everything with only a small singularity.
About 14 billion years later, the singularity inflated and has become what we've known today as the Great Universe.
Within the course of the Big Bang inflating, several phenomena were discovered in our universe.
This is Phyture.
And we're here to show you the science and beauty of the universe using physics.
Let's embark on a trip, starting here at the stars. Stars are the most broadly recognized astronomical objects in the night sky. Stars look like sky dust but are actually big in size. The basic life cycle of a star depends whether it is a low-mass star or a high-mass star. All stars start the same, in the nebula which will spin and spin until it creates a center mass. Once hot enough, the main sequence of stars begins. Low-mass stars are the smallest, coolest, and dimmest main sequence stars which are red, orange, or brown in color. Low-mass stars simply die by burning up their fuel to leave behind white dwarfs, which themselves cool and contract further to black dwarfs. On the other hand, high-mass stars are the largest, brightest, and hottest main sequence stars which are blue, blue-white, or white in color. High-mass stars pass through a red supergiant stage before dying catastrophically in supernovae explosions. Remnant stellar cores which survive supernovae can be sufficiently dense to form neutron stars, a star composed primarily of neutrons about 10 to 20 kilometers in diameter, pulsars, rapidly rotating neutron stars, or black holes, objects smaller than neutron stars with a gravitational attraction so strong not even light can escape. Why don't we go closer to home? To the moon, perhaps? The moon has many phases and types. One of these is the full moon, which occurs when we have a full view of the completely illuminated side of the moon. There are a few different types of full moons: blood moon, supermoon, blue moon, and harvest moon to name a few. Blood moon only occurs during a total lunar eclipse, when the Earth lines up between the moon and the sun. The term blood moon is also used when the moon appears to be reddish because of dust, smoke, or haze in the sky. Next is the supermoon, which looks larger than the usual size because it is a bit closer to the Earth. A blue moon is not really blue in color. It is just like a normal full moon, but it is special because it is an extra moon in the season with 4 full moons. The term blue moon has also been used for a second full moon in a calendar month.
If the moon changes its appearance, do all of the constellations always appear in the same place in the sky every night? If you will look at the night sky at different times of the year, you will see different constellations. Each day, a few stars are visible in the east that were not visible the night before. Their motion wending their way across the night sky is an illusion caused by the motion of the Earth in its orbit around the sun. You know what else is great in the night sky? Auroras. These are sometimes called the dancing lights. If you are near the poles, you can see this beautiful display of lights in the sky that appear in different colors, usually green, but sometimes violet, pink, blue, or even red. What causes these dancing lights? They appear when tiny particles stream out from the sun. As these particles reach the Earth's upper atmosphere, they give some of their energy to the atoms and molecules of gases there. As the particles arrive, the Earth's magnetic field guides them toward the poles. The said atoms and molecules cannot hold the energy, so the excess gets transformed into another kind of energy, the auroras. They are called aurora borealis when found in the North Pole, while aurora australis when found in the South. Such sight is really out of this world, like this one. Do you think it is an UFO? If so, you're wrong. These aren't UFOs, they're lenticular clouds. These are the stationary lens-shaped clouds that form in the lowest layer of the Earth's atmosphere, normally in perpendicular alignment to the wind direction. It happens when stable humid air blows over the top of a mountain range. It often forms a group of big waves on the range's downside. If the temperature there is low enough, the moisture in the air will condense to form these lenticular clouds.
Clouds. You know what else has clouds? Volcanoes. If you think that blasting of hot molten lavas and ashes is the only thing that volcanoes do, you thought wrong. After volcanic eruptions, volcanoes often produce a magnificent visual sight called volcanic lightning. This event happens due to the rubbing of the ash or dust particles produced by the volcano. Due to the friction of the ashes, there will be a charge imbalance where all the charges do not add up to zero, which eventually gets evened out by a sudden burst of moving charge in the form of lightning bolt. Yikes, that's pretty scary. But you know what's crazier than that? Pangaea. About 300 million years ago, during the Paleozoic and Mesozoic era, Earth didn't have 7 continents, but instead, it is believed that we have a supercontinent called the Pangaea, a massive landmass that is believed to be the origin of the continents. Due to the movement of the tectonic plates, the supercontinent Pangaea was divided into 7 continents that we know today. This movement was caused by the convection of the Earth's mantle, making the oceanic crust and the tectonic plates diverge with each other. This theory of Pangaea was proposed by Alfred Wegener, a German meteorologist who began to look for evidence to support the idea that the continents were once fitted together.
But is it all there is to it?
Can we really say that the universe is indeed beautiful because of that?
What made the universe beautiful?
We claim that the universe is beautiful, but we all know the beauty is in the eye of the beholder.
Some claim it's because of its forms or the elegance of theories, as the universe still proves its wonders as we go through patterns, forces, and many fascinating ideas that are interconnected, while others look at its simplicity, its richness, and most importantly, the idea that we can relate to it.
The universe is still expanding as we speak and still standing as an epitome of aesthetic perfection because of its geometrically balanced and well-defined form.
It's still far from being tired of going on, and it still keeps going from such length we can even begin to fathom. But one thing is for certain, their laws are our laws.
The underlying and overarching in these concepts become more evident as we go further, and there are many ways in which we connect with the universe as we dig deeper.
And how do we dig deeper? That's up to you, but you can start by finding the physics
Physics
Physics behind the nature.